Hello everyone, welcome to my channel, and we have basic gates here. We have here a NOR gate, OR gate, NAND gate, AND gate, inverter, buffer gate. This is our latest circuit, and we have the circuit diagram here. Transistor, NOR gate, and we have two transistors connected in this way. The output is taken in the center. We have here a Saki oscillator, this portion of the circuit, and this is the input circuit, switch A. This is the output. This is the input to switch B, PNP 557. And this is the NOR gate. We have a table for that. Switch 1B. So we're going to switch B here, and switch A is 0. Output 1, 0. Switch all of them. It's okay. Let us see the circuit. When you close the switch, the Saki oscillator is conducting. That is the Saki oscillator. Also, current flows only here at the center to the Saki oscillator and to the center, making the output of the transistor Q2 in cut-off mode because the push button is open. Here, voltage output of the transistor is cut. It means there's no collector current and voltage across CE. There's no voltage across CE. There's no current flows here because the push button is open. Also here, only here that the oscillator. This oscillator serve as a standby power on LED circuit. So the mission of this video, or the objective, is to operate in saturation mode. So when in saturation mode, the load line of the transistor is during cutoff IC is equal to 0, and during the saturation mode BCE is equal to 0. So there's no collector current during the cutoff. That's why current on flows from the oscillator and to the load line, or I mean to the center output. I'm using this type of configuration because of the Miller effect, the capacitance developed in the transistor, and I use this PNP circuit, which is our LED input disconnected, in order to prevent this Miller effect. Lots of capacitance developed in the transistor. So in here, I think there's no Miller effect here. With our new circuit. And I calculated also all the values of the resistor here. This is already calculated, the previous circuit and this one, by using KVL. I calculated the value of resistor here RD2 using KVL here. When you close the switch, push the button, current flows to the transistor and to the ground. Making the transistor operates in saturation mode. It means transistor is shorted here. When you push the switch, current flows here and in here. Current don't flow here because the resistance is lesser in the transistor, making this LED to become shorted. Just like the same here, same computation for this. I use KVL at R1. We have the symbol here, and let us check the other circuit. So this portion of circuits, the Sake oscillator. This is the input 1 circuit, this one. Output, that is in the middle. And then this is also an input 2 circuit using PNP. We have the layout here. So these are the complete parts. Isake oscillator, we have 470, 500, 470, PNP, 25 kilo ohms, NPN, NPN, PNP, 25 kilo ohms base resistor. of the PNP. The circuit here. This is a NOR gate. So current flows when you push the switch at the switch B. Here and here, two transistor conduct in operation mode in saturation by passing this LED because the voltage drop across LED is 2 volts. So when transistor operates in saturation mode, since transistor has a lesser resistance, current flows here and to the transistor instead of here when you push the switch. If we both press the switch, same things will happen. Push the switch, current flows to the two transistor and in here. Push the switch, current flows to the transistor and in here, not in here. It has 2 volts rating, the LED, and in here transistor has a lesser resistance. So that's the operation of the NOR gate, and this is the circuit diagram. So I have a buffer gate here, inverter, AND gates, NAND gate, OR gate, NOR gate. I think this design is working well because there's no, I can't see any capacitance developed in the transistor here in the LED, and the light of the LED, the output light is, we're getting a good light at the output. So that's how to operate the transistor nor logic gates. Just compute the current here to get the resistance value here, also here and in here, using KBL here and here. No input with output. We have output, switch B is 1, switch B, switch A, switch B 1, output 0. Switch A 1, output 0. Switch A and B in output 0. Yes, this is an OR gate. Okay, thank you for watching the video. Bye bye.